Hello and welcome to Upstream 2023. This is securing your open source project on github.com. My name is Jose Palafox and I'm a strategic application security executive here at GitHub. Loosely what that means is I work with our open source community as well as our largest customers here on the West Coast to adopt security features on GitHub and github.com. If you're not familiar with GitHub, GitHub is the home to all developers. We're the world's largest developer platform. We have over 100 million active developers making over 3.5 billion contributions annually. We're also the home to many of the top open source projects, and possibly including yours. Today, what I want to talk about are a number of security settings that you may not be aware of on the GitHub platform and share a couple of announcements that we made earlier this year around two-factor authentication. So we're going to be focused through this presentation on configuring settings in the GitHub UI using this security settings subpage listing here that I've copied in. But really, we're going to focus on two parts of that menu. One is the application security section. The other is the code security and analysis section, which has a whole bunch of static analysis tools packed in to help you better secure your project. So without further ado, let's get into it. First up, let's talk about authentication security. And really what I mean here is requiring a second factor of authentication for people to contribute code to your project. If we go ahead and click over into the organization that I created for this presentation, we can click into the settings section, drop down to the security subsection and click authentication security. Here, I'm greeted with this two-factor authentication security setting, and by checking this box, it will require two-factor authentication for everybody who contributes to my organization. And as this sort of orange box pulls out, if I enable this, it will boot people that don't have two-factor auth already set up. So this is not something you want to check without communicating to your open source community. But if you're collaborating with people in your own organization, you may want to require this as a setting for everyone that contributes to your project. If people don't have two-factor authentication enabled, they could be phished or their password could be guessed and their account compromised in some way. And if they have write permissions or permissions to edit the software in any way, that could be a dangerous situation for you and the consumers of your project. So by requiring two-factor authentication, we help mitigate some of those risks, and it's really easy to do it. You just check this button and hit save after talking with your community. GitHub is also taking steps to improve the percentage adoption rate of two-factor authentication. So in March earlier this year, we announced that we would be requiring two-factor authentication for anybody contributing on the platform by the end of 2023. So that date is coming really quickly. If you want, there's a QR code here. You can go and read the blog post where we made this announcement. But as a participant in the GitHub ecosystem, you'll be required to add two-factor authentication to your account sooner or later anyways. If you're a maintainer of a project, I think this is a great step to help secure you and your community. Also, we added two-factor authentication and our a time-based one-time password provider using our mobile app. So if you download GitHub Mobile, you can configure it to be your two-factor device. You'll get a push notification on your phone when you're trying to do certain activities on GitHub that would require you to authenticate. You just punch in a number to prove that it's you or that you have the second factor, and you'll be let through. So you can require this, and people can get you can meet the need, freely with the GitHub mobile app. So again, I left a QR code here for you to scan if you want to learn more about GitHub Mobile and how to use two-factor authentication with GitHub Mobile. And this is really a house cleaning step. So we'll just get this out of the way first. Two-factor is definitely something that you want to require and you want to think about requiring for your community. At a bare minimum, I would set this up for your personal account. Now we'll go ahead and dive into the more interesting, meaty part of this presentation. It's going to be that code security and analysis section. So let me click over and show you what this looks like. This is a big page. So as I dive into this code security analysis section, I've got a whole bunch of settings. I'm in an org level, so I can hit enable all, and that will require whatever the setting is for all of the repositories in the organization. This page looks loosely identical on the repository page, and I'll show you how to set things up repo by repo as well. But for right now, let's take a look at the org settings. So what I want to do is walk through each of these features and provide a little bit of context about what you would be enabling if you press some of these buttons. So let's get to it. First up is private vulnerability reporting. And private vulnerability reporting is a fairly new feature that we released. Again, link to QR code here to a longer blog for you to find out more about the feature. But basically what this does is it creates a security policy in the organization that allows outside researchers to securely disclose vulnerabilities they may find in your open source project. So if you're just authoring your project and not, doing anything, just minding your own business, but somewhere else, in the world has depended on your project and maybe has started to evaluate it for security concerns, they may find some vulnerability that you're unaware of and may want to let you know about it. When they go to do that, if there's not a paved path available to them, it's unclear how they're going to get a hold of you. If you have a public email address as a part of your GitHub profile, maybe they would email you, but you may not check that email very often, particularly if you're getting a lot of spam or recruiter emails. Maybe that's not something you check and you miss that security vulnerability disclosure. They may try to get at you on Twitter or something like that. But again, if you don't have high confidence that the handle associated on Twitter is actually the maintainer of the project, as the security researcher, you may not want to disclose it, or you may accidentally disclose it to the wrong user. And so using the vulnerability reporting feature, what we get is a secure way to communicate with security researchers that want to disclose vulnerabilities to us. I'll show you what this looks like in practice here. So what I've got is the JSON 5 repository up, and I've just clicked into this security tab of this open source project. Here you can see they have a security policy. This is just a security markdown file that's present in the repository, and they've listed that you can email them, but of course this runs the risk that the security researcher doesn't know who's on the other side of that email. They also don't know what to do if that domain bounces or the email's undeliverable. So by having private security vulnerability reporting enabled, you get this green button here that allows you to format a vulnerability. It will immediately issue a CVE, since we are a CVE enumerator, and this will go out as an update in Dependabot for anybody who's depending on your project. So it's a great way to notify all of your downstream users that there is a security vulnerability present, should this be a valid submission. So as a researcher, I could come in and just fill this form out, and then it would go securely to the repo maintainers to triage and work with from there. By using this feature, GitHub has become one of the leading open source CVE issuers. So for 2022, we issued more CVEs than almost anybody in the industry, and it's through this broad open source collaboration with all of you that we're able to do this. So thank you to everybody that used this feature last year and has contributed to creating more awareness of vulnerabilities that may be present in open source projects. And I'd encourage you to enable this feature and continue using it. Next up, we'll talk about Dependabot and the dependency graph. And so when you make a CVE for a project, if people are depending on that project will be listed in their dependency graph. Dependabot will also compare the dependency graph of a project to our vulnerability database. And if it identifies a package that is vulnerable, it will create an automatic pull request to update the package to a patched version, or at least to alert the user that there is a vulnerability present in that dependency. So let's take a look at what this looks like. Okay, so back here in our browser tab, we can go ahead and see where these features are located. So we've got the dependency graph here. We've also got Dependabot as options. Now, the dependency graph is grayed out, and that's because all of the repositories in this organization are public. And so dependency graph is automatically enabled for public repositories. If I had a private repository, then I would have the ability to enable it all here. I could also check this box to automatically require that everybody enable the dependency graph. Within this repository, I've started a couple of projects. So I forked a popular known insecure sort of sample application called Juice Shop. This is a hypothetical juice shop that has a bunch of insecure coding practices embedded in it. We're going to use this to look at how these settings work. So since the dependency graph is already enabled, I can go and click into Insights and then Dependency Graph. And this will tell me all of the packages that I depend on as a part of the Juice Shop application. So all of my dependencies are listed here, and the particular versions that they're pinned to are present as well. I can also export all of this information as a software bill of material. So this will output an SPDX file, which is a JSON file that's sort of a standard for sharing kind of what's in a software package out. So I can click this export SBOM and download an image of that. Now that GitHub is aware of all of the dependencies that I have in this project, it may want to notify me if there's a security vulnerability present on any of these. And so if I click into the settings again, into code security and analysis, I can see these Dependabot settings. So if these are enabled, they'll do a couple of different things. So the first thing that Dependabot alerts will do is it will notify me if there's a vulnerability on a dependency that I have. Dependabot security updates will take that notification and actually turn it into a pull request for me. And then Dependabot version updates will also make a pull request for me if I'm just out of date on a version. So depending on what my aim is in using Dependabot, I have a lot of control over how to set this up, but I can either be alerted or I can have automatic PRs created for me. When I choose to have automatic PRs created for me, this is kind of the developer experience that you'd be giving to your community. Within the pull request process, you can see that Dependabot's open to pull requests on my behalf. It's going to bump a package, and then it just asks me to go ahead and merge the pull request. So this is a really cool feature for automating version updates or automating security updates. Now, the reason it's really important to automate these updates is because if they're created on my behalf, I'm much more likely to accept them. Going through and actually making a pull request to update a package is sometimes a long process. By having Dependabot automatically update for me and create the PR, all I have to do is press that merge button, and maintainers are far more likely to accept those changes if the changes are made through this automated process. You can see that blue line there is the percentage of pull requests that are accepted automatically with Dependabot versus when we require maintainers to create these updates on their own. The next section we're going to look at in the UI there is called code scanning. Code scanning is a static analysis security testing tool, or SAST is the acronym that's sometimes used. You may have heard of tools like MobSF, which is an open source security scanning tool for mobile applications, or you may have heard of a tool called Psalm, which is an open source tool for scanning PHP. CodeQL is our static analysis tool, and it covers all of the major enterprise languages like Java, JavaScript, TypeScript, Ruby, Python, C, C++, C#, and so on. So it's a really strong research tool that covers a lot of languages, and it's available to you free as an open source project maintainer. What it does is it looks for insecure coding patterns that may be present in your code, and then creates a list of vulnerabilities for you within the GitHub UI that you can triage at a later date. So if I go into the code scanning section of this page, I can see CodeQL analysis. I can click setup. Here, I'm going to use the default setup because Juice Shop is written in an interpreted language. And so there's really no configuration that I have to do. I can just click default and it'll go ahead and enable this for me. So I'll set that up and we can come back and look at what the results look like here in just a minute. If you have a project written in C or C++ or some compiled language, you may need to do the advanced setup, and this box may be grayed out on you. What you'll have to do is copy the build script for your application into the CodeQL configuration file, because the way CodeQL works, it interacts with the compiler and structures the code as a database. And so in order to do that, we have to monitor the build process. So if you're using a compiled language, it's slightly more complicated to set up, but really not too difficult. If you're using an interpreted language, which we also include Go, as an interpreted language here, you can just go ahead and click the default setup, and you'll get a pretty good experience with the default rules. The last setting you'll see here under code scanning is this pull request check failure. And what this is going to do is set a branch protection rule to fail PRs that fail the CodeQL analysis step. So if you want to set this up for your community, you may want to start it with this none as the security failure step. Same with other here. What this will do is basically set this in a observation mode. So it'll report the vulnerabilities. Developers will be able to see the failures, but it won't reject any PRs until you've talked with your community and kind of understood what the impact of this will be. Over time, I think we recommend that you move to failing PRs that introduce high or critical vulnerabilities. And so you would just set that here with the higher setting. What that will do is if somebody introduces a vulnerability into the code base that is a critical or a high, we will go ahead and block the PR until they remediate it. And this is an overall security feature is really powerful for the community. When we look at all of the code that's hosted on GitHub, the majority of applications have at least one security vulnerability present in it. And only 33% of security vulnerabilities that are identified by the community are actually fixed within 90 days. So there's not very much response to security vulnerabilities, and they're kind of all over the place. So by using CodeQL and inserting the CodeQL results into the PR process, we noticed that developers more than doubled the remediation rate than they had previously. So over 72% of the CodeQL blocked PRs get remediated during the pull request workflow, and then the pull request is completed. So by using this feature, you'll weed out contributions that may introduce security vulnerabilities into your project, and the contributor of those vulnerabilities will be able to see the alert from CodeQL. There's a lot of metadata associated with it that tells them how to do the remediation steps or what the vulnerability is and what to do with it. So if we look at a CodeQL vulnerability, you can see I've got one here, and Sebastian has gone ahead and added some code to this project. And you see he's getting a parameter from the user, which is the user ID, and then they're going to generate the name of a JSON file using that user ID. And when you do that, you want to sanitize that user input so that they're not putting anything malicious into it, because that will get picked up later on. So this is what a vulnerability looks like. It's flagged this uncontrolled user input that's happened here. I can click in and see more details about this vulnerability. And this is kind of the developer experience that your community would have when CodeQL is enabled. They would get, the line number as well as, step-by-step information about how the vulnerability traverses the code. They'll also get a whole bunch of good information about this type of vulnerabilities. So we cite the CVEs that are relevant here, or CWEs that are relevant here. We provide references to the developer, and kind of with all of this information, they're able to remediate these vulnerabilities at a much higher rate than the industry average. The last feature we're going to talk about is secret scanning. I've worked on secret scanning for a number of years. Really, I go out to the open source community and talk to the world's largest SaaS providers and platform providers, developer tools providers in the world, and talk to them about how they structure their API tokens. When we understand how the tokens are generated, we can write a regular expression to identify those tokens if they're accidentally leaked in source code. So on every commit to github.com, we're scanning for API credentials that may be leaked in the platform. So I'll show you kind of where this setting is here. We can go ahead and click enable. And what this will do is start scanning every commit that a developer makes to this project and look for common API token patterns. So these could be Azure API keys or AWS API keys or Artifactory tokens or something like that, that they may accidentally copy and paste into their code when they should be properly obfuscating that in something like Azure Vault or HashiCorp Vault. if we identify these tokens using this feature called push protection, which I'll also enable here, it will actually block that commit from coming into GitHub, and the developer will be met with a standard out from their IDE saying, hey, you've introduced an API credential at a certain line, you should go ahead and remove it and then re-push this. If for some reason a developer needs to commit something, they can, or if they need to commit an API key because it's a test or it's an already invalid credential or it's a false positive, they can do that. And what you're seeing here is the override process. So there's a URL that comes out in the error alert, and that will allow you to go ahead and push the secret. And then you can see here that secret is pushed and labeled as a false positive. So we can just watch this one more time so you kind of have your bearings. Here's the URL that we give you to override it. You can paste that in. It'll take you to this page where you can mark why you're overriding the secret, and then you can re-push it, and that alert will come into the project and be recorded, but also recorded as a false positive or as some other vulnerability type or sort of some other triage state already. The last thing I want to show you is how you can use code scanning with other tools. And in particular, I want to talk about this OpenSSF security scorecard. What I've showed you today are some quick and easy features that you can get enabled, but other parties have been working on this for a long time. And there's actually a tool called the OpenSSF Scorecard that gives you kind of a checklist inside of the code scanning UI to kind of have for later. So you can run the scorecard, it'll evaluate your project and then give you a list of steps that you may need to take to put your project in a more secure state. So here I'm just going to go ahead and commit the OpenSSF security scorecard project and get this running. So I'll click over to actions and see if this is working. It looks like it's in queue now. So here's the project that I set up CodeQL on earlier, and let's dive in. All of the scans have already happened, so we can go into the code scanning alerts, and you can see that it's found a number of hard-coded credentials. We found, code injection. Again, this is a intentionally insecure application, so it's a great test bed for us to find security vulnerabilities in. So if you want, you can fork that OWASP Juice Shop project, run it just like I've shown you here in the default configuration, and you'll get a whole bunch of vulnerabilities that you can take a look at later and get an experience for how this would work on your project. As soon as the OpenSSF scorecard tool is done running, it creates a whole bunch of alerts here that are related to changes in the repository that the OpenSSF scorecard wants to see. The OpenSSF, by the way, is the Open Source Security Foundation, and they've created this tool to help open source maintainers improve the security posture of their applications. So what you're seeing here is, the scorecard is advising me that there should be, this CodeQL tool enabled, and it probably just missed it because it was setting it up. If I had CodeQL set up earlier, before I ran Scorecard, it should have picked up that CodeQL is already enabled, and this wouldn't be an alert. You can also see that it wants me to enable, a fuzzing tool here. What else in here? It wants to require code review. So this is, another setting that we didn't talk about, but this is saying, hey, you should require a code review on this project before accepting any contributions. So this is a really good health check for you, and it's kind of the last step I'll leave you with before we move to questions. But this will give you a to-do list of additional security enhancements you can make to your project just to put it in a more secure posture. So link the QR code here again. And thank you so much for taking 20 minutes out of your day to kind of hear about these features and how you can improve security for your project on GitHub. Hope you have a wonderful conference.